Hey guys, today's video is about information gain. Although the concept is not difficult, the calculation process is a little bit annoying. So I'll make two videos to introduce information gain. To begin with, information gain is an attribute selection measure used to find the best splitting criterion for a decision tree. For instance, we have this decision tree. We want to know whether a person will buy an iPad or not. During the process, we ask three questions: the age of a person, if the person is a student, and if the person has a job. However, which question should we ask first? This is when information gain can help. Basically, if we choose information gain as splitting criterion, the decision tree selects the attribute with highest information gain to split on. The first concept we need to understand is entropy. Entropy is the expected information required to classify a tuple in a database. In other words, entropy measures the level of uncertainty. For example, if we only have one class in an attribute, we know each tuple must belong to that class. Then the level of uncertainty is 0, so does the entropy. Second, to classify a tuple, we must have one target attribute, and that target attribute is our interest. The formula of entropy goes like this. We denote entropy of a database as info D. Because entropy is the expected information required, so entropy is the negative summation of Pi times log base 2 of Pi. To illustrate, D stands for the database. The M in the summation is the number of classes in our target attribute. Then, Pi is the number of data points belonging to class I divided by total number of data points. Don't worry if you are still confused. Let's look at an example. Say we have this database with 5 data points. Each data point has 3 attributes. If the person is a student, the age of that person, and if the person buys a computer. Our target attribute is buying a computer. That is, we want to predict whether a person will buy a computer given the student identity and the age of that person. To calculate the entropy of database, we only need to look at the target attribute, buying computer. Next, there are 2 classes in this attribute, which are yes and no. Therefore, the M in the formula is 2. Further, there are 3 people buying a computer, 2 people don't. Now, we just plug in the formula. The entropy for this database is 0.971. Specifically, the orange part is for class no, since Pi is 2 over 5, which means 2 out of 5 people don't buy a computer. Following this, the purple part is for class yes, since 3 out of 5 people buy a computer, and that's how we calculate the entropy. Before ending this video, I want to talk more about entropy. Entropy is the information required to classify a tuple, and it ranges from 0 to 1. In other words, entropy 0 means we don't need extra information to classify a tuple. In fact, this is the best situation since the attribute is pure. For example, the attribute buying computer now contains 5 yes and 0 no. Then, we know that everyone in this group buys a computer, since there is only one class left. To verify, we use the formula to calculate the entropy for this database, and it's indeed 0, since the log base 2 of 1 is 0. Therefore, we conceptually and mathematically confirm when the attribute is pure, the entropy is 0, since we don't need extra information to classify a tuple. On the other hand, the entropy 1 means we don't have any useful information. Say we have buying computer attribute, but this time we have 2 yes and 2 no. If you think about this, you will find this attribute has 50% chance yes, 50% chance no. So, if someone asks us whether the people tend to buy a computer or not, we have to make a random guess because we don't have any useful information. Mathematically, the entropy of this database is confirmed to be 1. Thus, the entropy 1 means we have to get all the information from other attributes, so we don't prefer splitting on this kind of attribute. Alright, that's the basic concept of entropy. We'll continue our discussion in information gain in the next video. Thank you for watching my video and see you soon.